What do you mean by data abstraction here? It's a process of representing essential detail by hiding background detail. We mainly focuses on the relational data models. For example, when I'm representing my data models in terms of relations or in the terms of tables, then we are going to call that as a relational data models. Based on the concepts that to describe the database architecture, based on that we are going to categorize this data model. Everybody, a warm welcome to one and all. Welcome back to the chapter 2 session 1 of unit 1 of B.C.A semester 4 subject called database management system, in short DBMS. I'm Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. In our today's session, we are going to learn about the data model, and also I will be discussing regarding categories of data models. Then we'll see about the schemas versus instances. That means what do you mean by schema and what do you mean by instances? What is the difference between those two? That I will be discussing in my today's session along with the database schema and database state. So before that, as we all know that in a client server DBMS architecture, the functionality of that architecture will going to be based on two modules. So first module is what? Client module, and second module is regarding server module. So we have two modules, one is client module and another one is server module. So when it comes to the client module, it will going to be focused on its GUI, that is graphical user interface, how the data needs to be seen by the user, like how it look like to the user. So its interface will going to be take care with the help of this client module that will going to be takes place in that workstation. But when it comes to the server module, it will going to take care about its storage space, how the data needs to be represented, where it has to be stored, how the data has to be viewed to the user. So that will going to be stored in the server module. So in order to understand the architecture, then we have to understand the data model first. So now we'll see about the data model. So as we all know that we are familiar with the word called data abstraction. So I have already discussed regarding data abstraction in my last sessions. So what do you mean by data abstraction here? It's a process of representing essential detail by hiding background detail. So if you take an example of refrigerator usage, or you can take the example of washing machine. So we all know how to operate it, but do we bother about how it is working internally? Somehow no, right? That means what? We are getting only essential features by hiding the background details. And in order to implement or in order to illustrate the data abstraction, we are going to use a concept called data model. So this data model is used in order to implement the data abstraction. What is the main thing here? We are suppressing the detailing of a data, how it is working internally. In spite of that, we are just giving how to get a benefit out of that data. That is what data model or data abstraction is all about. So when it comes to the data model, you have to remember three keywords here. So what is the first one? That is structure of a database, and also operations for manipulation, then constraints that needs to be obeyed. So now what you have to understand, you just imagine like if you wanted to build any of the house or any of the construction you want to take place, at that time are we going to build it directly without doing any planning? No, right? We are going to have a blueprint, like somehow it should come here and the dimension should be like this. We are going to have some representation of that blueprint. That blueprint of a database is also called as what? Structure here. So that structure of a database will going to tell us what must be the type of a data, how many datas I have, and how must be the table needs to be constructed, like how many columns it should include. So and each column what type of data it can hold, that represents the structure. So data model will going to describe the structure of a database, how many tables it has and what is the number of columns in each table and what kind of data I can add. So that and all will going to be described in the structure of a database. And when it comes to the operations for manipulation, so operations include either updation, alteration, or if I wanted to insert some data, if I wanted to delete some data. So all those will be considered as what? Operation. I'm doing some manipulation in order to get the benefit out of that. And also we have constraint. So as I told, constraints are nothing but rules. For example, if I wanted to admit any of the student for first PUC, at that time what their age must be? It must be greater or equal to 15 years. So I should not take any student those who are lesser than the 15 years. That is what I am giving some rules that needs to be obeyed. Then only we can admit them for the college. That is what the constraint is all about. So here, data model or a data model concept, it is a set of concepts that describes the structure of a database, the operations for manipulating these structures, and certain constraints that database should obey. So it has to describe how must be the structure, and it has to tell us what are the operations that I can perform on that structure, and also what are the constraints or rules and regulations that we have that needs to be followed by the database. So we got to know the things regarding with structure, and also we have constraints here. So constraints why we are going to use in order to define the database structures. So this will going to includes the element or as a group of elements. So that will going to be help us in order to specify the rules and regulation that needs to be followed by the database structure, and it also specify entity, record, table, relationship among one data to another data. Everything needs to be represented with the help of this constraint. And also in order to give the security and privacy for the data, we are going to use this constraint so that it specifies some restrictions on a valid data. So these constraints must enforce at all the time. So if we have a constraint, if I wanted to include another data or a new data, at that time also the new data has to satisfy this constraint. That you have to remember here. So next what we have here, as I told, we have operations. Then what kind of operations can be performed by the data model? So these operations are used for specifying the database, retrievals, I am fetching some data, and updates by referring to the constructs of the data model. So operations that includes retrieval of the data or updation of the data. And also operations on the data model may include basic model operations. So that includes like inserting, deleting, update. And also when it comes to the user defined operations, that includes computation of some of the student marks or computation of the salary of an employee. So those can also be taken as an example. Mainly if you consider a structure that defines how the table must look like and what are the data I can include, what is the data type of that particular column, that is structure. And when it comes to the operations, we can perform retrieval or updation with respect to data model. So, and also we have a constraint, that is a set of rules and regulations that needs to be obeyed by the database structure. So next we'll see the categories of data models. So we have three categories here. One is conceptual or high level or semantic data models, and also we have physical or low level or internal data models. Next we have implementational or representational data model. So totally we have three categories in the data model. So as we all know that data model is all about structure, operation and constraint. So remember that as SOC. So if you remember these keywords, it has to be used when we are writing the definition for data model. We'll see the first one, that is conceptual or high level or semantic data models. So you just imagine we have three layers here. We have three kinds of data models. Then why we are going to use this data model, like on what basis we are going to categorize this data model? So based on the concepts that to describe the database architecture, based on that we are going to categorize this data model. So totally it has three types: conceptual, physical, and also we have implementation. So when it comes to the conceptual, it is the high level. So as the name indicates, high level in the sense what? The abstraction will be more. So before this data model, I had discussed regarding data abstraction. So there we are going to focus on the separation of a detailing of a data to the end user. They just wanted to know how to use instead of knowing how they has been arranged or how the manipulation has been done, from where we are getting the data. That should not be known to the user. So when it comes to the conceptual or high level or semantic data models, at the time it has higher highest level of abstraction. So what and all we are getting, like what and all we are accessing in the database, what can be viewed by the user will be considered as what? High level or semantic data models. So here it will mainly going to focus on the three things. That is what it focuses on: entity, and also it focuses on the attribute, then it focuses on the relationship. So what do you mean by entity here? So entity can be any object. For example, can I take an employee as an entity? Yes. Can I take student as an entity? So we can take. That means what? An entity is nothing but it is an object that represents the real world scenario. And attributes are nothing but it characteristics. So that represent its characteristics. So in the entity, that will going to be described with the help of rectangle box. So if I consider this as an entity, then that needs to be specified within rectangular box. And if I take an attribute, those are all the characteristics, so that specify its nature. And also relationship is nothing but it can be relation like from one entity to another entity, how one entity is related to another entity. For example, if I consider an example of student, let me consider student is an entity. Okay, then what student comprises of? Student ID will be there. For student we have name, and student will going to have a age or date of birth. So all these are what? So this is an entity and all these are the attributes. Then how student is related to another entity called course. So that is what relationship is all about. So in the conceptual or semantic or high level data model, they are mainly focusing on how user is getting the data. So that mainly focuses on three things: entity, attribute as well as relationship. So when it comes to here, provide concepts that are close to the way many users perceive data. And also we are going to call this as what? Entity based or object based data models. So I can consider this entity as an object, and how object is related to one object to another object, that is relationship. And what are the characteristics it include? That represents the attribute. This is regarding what? Conceptual or high level data model. So we'll see the second type, that is physical or low level or internal data models. So as name indicates, low level in the sense what? In this low level or a physical level, we are going to have access to the stored database. So that is what you can see here. It provides a concept that describes the details of how data is stored in the computer. So in the physical level, we will get to know how the data has been stored in the computer memory or a computer storage space. So here in the physical data models, it will going to represent or it will gives the information regarding how the records has been represented, what is the order of recording, how it needs to be accessed, and mainly what is its access path, how can I get this data or information which is present in the computer memory. So that will going to be represented in the physical or low level or internal data models. And also it's specified in an ad hoc manner through DBMS design and administrator manuals. So this physical level is not going to be accessed by the user. So user will not get to know what is there in the physical data model. They will just have access to this conceptual data models. So in the physical level, mainly it will going to store the data and information which is required for my DBMS. So next we have implementation or representational data model. So this will comes in between the conceptual as well as the physical. So this will going to work as a in-between layer of conceptual as well as the physical level. So this provides a concepts that fall between the above two. That means it falls between the conceptual as well as between the physical. So that which will be used by many commercial DBMS in order for the implementation. So here we mainly focuses on the relational data models. For example, when I am representing my data models in terms of relations or in the terms of tables, then we are going to call that as a relational data models. So based on that scenario, this implementation or representation data models will going to work. So in this implementation data model, it specifies the relational DBMS and also it specifies the programming language. How can I access the physical data and how can I reach it to the conceptual level or to the first layer called high level or semantic data model. So this is the usage of this implementation or relational data models. I hope you all understood. We have three categories: conceptual, physical, and also we have implementation. First level is what? Conceptual level. Second, in between we have this intermediary level, and we have physical data models. So now we'll see the next topic, that is schemas versus instances. So as we all know that it is mandatory to differentiate between database and database description. Okay, so you have to differentiate what is you and what is the features or what are the properties of you. That means you have to differentiate database and description of the database. So in order to give the description of a database, we are going to use a database schema. So as I told, needs to be differentiate between database and database description. In order to give the explanation or in order to represent that description of a database, we are going to use this database schema. So that description of a database is called as what? Database schema. Then what these descriptions include? So what I can say as a description of a database schema, so this includes the description of a database structure. So we have to specify the structure of a database and data types, what kind of data it is able to allow, and also the constraints on the database. So if I say schema of database, that include database structure and also it must include the data types along with a constraint that database needs to be satisfied. That we are going to call that as a database schema. Then if I am representing this schema with a diagrammatic representation, then I am going to call that as a schema diagram. So that is an illustrative display of the database schema is called as schema diagram. So we are representing that schema, and that schema comprises of what? It has a database and also it has the data type and it has a database structure along with a constraint. So if I am representing that with the help of some of the diagrammatic representation or a pictorial representation or this illustrative display of that database schema will be considered as what? Schema diagram. So next, here you can see that schema construct. That means, what do you mean by schema construct here? A component of a schema or an object within the schema. We'll show you one thing here. So here you consider student as a schema and course is a schema and prerequisite is a schema. How can I consider this as a schema? If you consider the student, so I have a table and I have a structure for that database, and what it comprises of, what kind of data it will going to take. For example, it has a name, so it will going to take varchar. And if I take a student number, that will going to take either only characters or only numeric value. And also we have a class and major as CS, bio, like that. Okay. So if I consider a student as a schema, that includes, what it includes? It has a database structure and it has to specify the data type along with some of the constraints. So that I am representing it with some of the illustrative representation. Then I can say this as a schema diagram. So now you can see here, then what do you mean by schema construct here? A component of a schema or an object within the schema. Then I can consider all these as a schema construct. So name, student number, class, major, all these considered as what? Schema construct. So next we'll see about the database state. What do you mean by database state here? So the actual data stored in a database at a particular moment in a time, that will be considered as what? Database state. So database is comprises of number of table, and each table will going to have a number of rows and columns. So here you can see that example for database schema, and we have a course name, course number, credit hours, department. So what I am discussing about now, that is database state. So what is the actual data that I have at a particular time, that will be considered as what? Database state, and also it is considered as a snapshot. So if you see this schema, here I have a actual data, I have a rows, I have a values for that. That will be considered as what? Database state, or the particular value, whatever we have at a particular time will be considered as a database state, and each state should follow the constraint and it has to follow the structure and it must perform some of the operation, and it is also called as what? Snapshot. We'll see the next definition, that is regarding what? As we all know that in the database state, this includes the collection of all the data in the database. So as I shown the example there, that includes the collection of all the values in the database. That will be considered as what? Database state. And also we are going to call that as a database instance. Remember, we are going to call that as a database instance or occurrence or snapshot. So we have a synonym for this database state that includes, either we can call that as an instance or an occurrence or as a snapshot. So the term instance is also applied to individual database components. So if you consider this database state, we can apply that to the individual database components also. That may include course, student. So in that way also you can take. Or else if I consider all the data, what actual data that we have at a time will be considered as what? Database state. So next we'll see about the database schema versus database state. So now it is mandatory to differentiate between database schema and database state. So you just imagine when I say database schema, what it comprises of? Database schema include the structure of a database, and also it specifies the data type, and also it specifies the constraint what needs to be satisfied. That is regarding what's database schema. And what do you mean by database state here? That represents the data which is present at a particular time in the database. So when you are creating a new database, or when we are structuring a schema of new database, at that time the database will be empty. Okay, so when I'm giving some data or when I'm inserting some data, then only the initial state will going to be generated. So when we are structuring or when we are defining the database schema, at that time, so I will give you an example here. Here I am creating a database schema. So that shows what it has, how many tables and what is the data type and how many values it can include. That is what schema here. So when I'm creating this database schema, at that time the values are empty here. But when I'm adding some content to that particular database, at that time it will going to generate some values, and that values will be considered as what? Database state. That is the difference between database schema versus database state. So as we all know that, we already know the definition of this database state, that includes the content of a database at a moment in a time. So whatever the content I have in a database at a particular time will be considered as what? Database state. And when it comes to the initial database state, that refers to the database state when it is initially loaded into the system. So as I told, when it is the database schema is represented, at the time it was empty. So when I am loading a new data to this database, at that time we are going to have some initial data or values. So that will be considered as what? Initial database state. And also we have a valid state. So whatever data we have, that has to follow the database structure, and it must follow the types of data types, and it must obey the constraint. Then only I can say that as a valid state. So here a state that satisfies the structure and constraints of the database will be considered as what? Valid state. So if I consider any point of time, at the time whatever the data we have or whatever the database state we have, every data needs to be validated. Then only I can say that as what a schema is represented or a schema is developed in a such a good or efficient manner. So when we are creating a schema, we have to take utmost care. So why? Because based on that schema, all the data will going to be stored. So if I am not specifying any of the constraint, or if I am not good at specifying any of the particular data type for my database, at that time then there will be a misusage of the data will going to be takes place within the database. So it is necessity in order to take care about when we are having the scheme of data structure. We'll see about the distinction. So here we have to distinguish between the database schema and database state, right? So here you just imagine we have a college, we have a classroom, and construction of that classroom will going to take place only once, right? So that means frequently it will not going to be renovated. So that I can consider that as a database schema. But what about student? So this year some of the students will come and sit there. By next year another batch of students will come and sit there. That means what? Changing of database state can be takes place frequently, but changing of a database schema should not takes place frequently. So that is what the distinction between the database schema as well as database state. State can be changed frequently. That means if I add new content, then the state of that database will going to be changed. But if I wanted to change the overall schema, it should not take place frequently. Then there will be a chances of having the inconsistent data. So that is what the reason. So here the database schema changes very infrequently. It is not frequently changing its schema. That means we are not changing the structure, we are not changing the constraints or a data type. That is what you can see here. And the database state changes every time the database takes its updation. So if I alter some content or if I delete, update, if I do any manipulation over the data, then the database state will going to be changed frequently. So here schema is also called as intention, and database state is considered as extension. So this is what you have to remember. Schema is called as intention and database state is called extension. So here you can see the example of a student, course and prerequisite schema. All will going to represent its data structure along with the type as well as constraints. So and also here we have an example for database schema of a course that include course number, credit hours and department, and all these will be considered as what? Instances, right? So or as occurrences or a snapshot. That means what is the data that we have at a particular time will be considered as an instance or a snapshot or as a occurrence. So here also we have one more example. So it's all about today's session. So in my coming session we will be discussing regarding the 3 schema architecture, and also we'll see about the data independence. I hope you all understood my today's session. Let me meet you in the next session with a 3 schema architecture along with the data independence. Until that, keep learning, keep on growing. Thank you.